All right, so for our problem, we have to find the energy stored in this capacitor. So we're left with this circuit diagram, and we're starting off with these two, and we know they're in series, so we can use this equation, 1 over the capacitor equals 1 over each of them. Just kind of do some algebra, and you get 6, and then we redraw the circuit diagram, and we're left with this. And these are in parallel, so you can just add them. 6 plus 6 equals 12. And then we move right here. Again, these are going to be in series, so we use this equation. 1 over 12 plus 1 over 4 equals 3. And that is the the capacitance equivalence for this circuit diagram. And then we're going to need to work backwards to find the energy. I can take over.
So once we know the C equivalent, we can use the delta V, which is 8 volts, and use this equation Q equals C delta V to get the 0.024 coulombs. And from there we have to work backwards, so we know that these two are in series, so they'll have the same charge. And we can use that same charge that we got from here and find the voltage difference in each of the capacitors. And from there we can move to this diagram, and we know that these two are in parallel, which means they're going to have the same voltage. And we know that this has a voltage of 2 volts, so we know that both of these have to be 2 volts as well, and we can use this equation to find the charge in that. And from there we work backwards again.
So because these two are in series, they are going to have the same charge, so we use what we found here to get and we use the change in voltage equation to get change in voltage is 1.33 volts, and then we can plug that in up here to get, so you plug in the charge and the change in voltage to get a